So in this video, I am going to show you how to work with quadratic equation application problems. Those are the type of problems that you see in real life situation where you can use quadratic equation to solve for it. Okay, so let's take a look at this one right here. So here we have a situation given the width of a rectangle is 6 meters less than its length. If the area of a rectangle is 112 square meters, find the dimensions of the rectangle. Okay, so you're looking for the dimensions of the rectangle. So it's a what by what rectangle. Okay, so you're given the area of the rectangle, given the width, and you're looking for the length. So once you find the length, you can find the width, and then just make sure that when you multiply those two numbers, it comes out to 112 because that's the area. So the area is to take length times width. Okay, so here's the rectangle. The width is 6 meters less than its length. So we do not know what the length is. Okay, so we're going to call it x. So your length is going to be x. But we know that the width is going to be 6 meters less than the length. So that's going to be whatever the length is, it's going to be minus 6. And then the area, so the area we know the area is length times width. The area here is going to be 112. So when you take x times x minus 6, you get 112. Okay, so we're going to set this up, okay, into a quadratic equation, and then we can solve that quadratic equation to find out what x is. So you're going to have length times width, so that's going to be x times x minus 6. So that is your length times width, and then it's going to come out to 112. Okay, and then we're going to solve for x now. So here we have to distribute the x to get rid of the parenthesis. So you end up with x squared, take away 6x equals to 112. This equation is a quadratic equation because of the x squared. So now we're going to solve for x. So first thing we have to do is to set it equals to 0. So I'm going to have to minus 112. So I have x squared, take away 6x, minus 112, so I can have 0 on the other side. There's many ways that you can solve quadratic equation, but if this can be solved by factoring, you want to solve it by factoring because it's a lot faster than try to do it by completing the square or using the quadratic formula. See, we can factor this. Okay, if we can get it done a lot faster. So to factor, first thing you do is find a times c. So a is 1. Okay, a times c, that's 1 times negative 112. So that's negative 112. And then your b is the coefficient of x, so that's negative 6. Okay, so you get a times c, that's this, and then this is your b, negative 6, and that's that. Okay, so now you have to come up with two numbers, factors of negative 112, that when you add those two numbers, it comes out to negative 6. The factors of negative 112, so you're going to need a negative and a positive, and then when you add those two numbers, comes out to negative 6. Okay, how about we use 14 and 8, but one of these numbers has to be a negative number. Okay, you want to end up with negative 6, so the 14 has to be a negative number. Negative 14 times 8 is negative 112. Negative 14 plus 8 is negative 6. These are the two numbers that we're looking for. Now we're going to go back here and use those two numbers to put it in factor form. So it's going to be x times x to get x squared. It's going to be negative 14 and then plus 8. Okay, so if you were to multiply these two factors, you get this. Okay, so now what we do is we set each factor equals to 0 and then we solve for it, and that's how we come up with x. So x minus 14 equals to 0. So this here, what we get 14. Okay, so x is 14 for this one. And then the other one is x plus 8 equals to 0, right? And then when we solve, we get negative 8. Okay, so those are the two answers. Now, if you look at these two numbers, since we're talking about how long it is, this number right here is no good. Okay, the length of a side cannot come out to a negative number. So this one's no good. So, okay, so x is 14. So the length is 14. And then this one would be 14 take away 6. And that's going to give you 8. Okay, so this one would be 8. So this is a 14 by 8 rectangle. So we go length is 14 meter, and then the width is 8 meter. Okay, so it's a 14 by 8 rectangle. Let's take a look at another one here. Okay, this is another quadratic application problem. Okay, so what information do we need to solve this problem? Well, let's take a look here. So the base of a triangle is 7 less than twice its height. If the area of the triangle is 102 square centimeter, find the length of the base. Okay, so you're given the base. The base is 7 less than twice the height. Okay, so let's draw a triangle here. So here is a triangle. We do not know what the height is, so we're going to call it x. And then the base of this triangle is 7 less than twice its height. Okay, so we know the height is x, so twice of the height is 2x. And then take away 7. And we know that the area is 102 square centimeter. All right, so this is what's given to us right now. Okay, so what do we need to, in order for us to find what x is? We need to know the formula for the area of the triangle, because we have base, height, and then area. So the areas of the triangle, formula for areas of a triangle is A equals to 1/2 base times height. Okay, so now we have all these numbers that we can plug in, okay, and try to find what we're looking for. So we have the area, so we're going to plug 102 for A. So 102 is 1/2. Now my base is 2x minus 7. And then my height is x. Okay, so this is the equation that I need to solve for x in order to find what the height is. Okay, so here we have 102 is, well, I'm gonna multiply the 1/2 with the x. So now I have a 1/2 x, and then I'm gonna use that to times it with 2x minus 7. Okay, so 102 is, distribute the 1/2 x to get rid of the parenthesis. So 1/2 of 2 is 1, so this is going to give me x squared, 1x squared. And then here is going to give me negative 7 over 2x. Okay, so what I have now is a quadratic equation because of the x squared. Here I also have a fraction. So I do not like to work with fraction. So I can get rid of the fraction. Okay, so I can make that fraction go away by multiplying everything by 2. Because if I multiply this by 2, I'm going to be able to cancel the 2. Then I got to multiply the x squared by 2. Then I have to multiply the 102 by 2. So this times 2 is going to give me 204 is 2x squared. Take away 7x. I'm going to try to solve this by factoring, because if I can do it, I can save myself a lot of time. So to solve this by factoring, we're going to set it equals to 0. So here I have 2x squared. Take away 7x. Minus 204 is 0. Okay, so what I did is I got rid of the 204. Then you have negative 204 on this side, okay? All right, so now I'm going to try to factor this using the AC method. So my AC is going to be A times C. So that's 2 times negative 204 is going to give you negative 408. And then my B is negative 7. So now I have to come up with factors of negative 408 that when I add those numbers comes out to negative 7. How about 24 and 17? 24 and 17, and this got to be a negative 24 to make it come out to that. All right, so look, negative 24 times 17 is negative 408, and then negative 24 plus 17 is negative 7. Okay, so these are the two numbers I'm looking for. Okay, so here I'm going to write it out in factor form. So it'll be x minus 24 times x plus 17, and that equals to 0. Okay, and then because I have a 2 here, not a 1, the coefficients of x squared is 2, I would have to divide this by 2. And this is called the slip and slide method for factoring. So here I end up with 12. 2 goes into 24 12 times. 2 cannot go into 17, so the 2 goes to the front. So you have 2x plus 17 is 0. And then set each factor equals to 0 to solve for it. Okay, so when I solve this one, I'll get 12. So x is 12. And then over here, x is negative 17 over 2. So based on what we're looking for, okay, this number here is no good. Because remember, we're looking for the height of a rectangle. Okay, the height cannot be a negative number. So the only one that is going to work for this situation is the 12. Okay, so we can go back up top. Okay, so we found x. So that means the height is going to be 12 centimeter. And then the base two times 12 is 24. And then when we take 7 away from 24, we get 17 centimeter. Okay, so what are we looking for here? We're looking for the base. Okay, how long is the base? And we found the base to be 17 centimeter long. Okay, so let's take a look at another one. Ken has a rectangular shaped vegetable garden that is 15 feet by 9 feet. He would like to increase the length and width by the same amount, x, so the new garden is twice the current area. Find the value of x to the nearest tenth of a foot. Okay, so first thing I'm going to do here is draw a rectangle. Okay, so this is a 15 feet by 9 feet. And the areas of this is length times width, which is 135 square feet. What he would like to do is to double the area of this rectangular vegetable garden. The areas of the new rectangular garden is going to be 270 square feet. Okay, so the original is 135. So if you double 135 plus 135 is 270. So here from the original side we have 15, and then this is 9. So the original was a 15 by 9. How much more do we need to add to 15? And then how much more do we need to add to 9? That when we take length times width, we get 270. Okay, so we're looking for this x. So x is going to be the same amount. How many more feet do we need to add to 15? How many more feet do we need to add to 9? That when we multiply, we get 270. So we're going to set up a quadratic equation. To find the areas of a rectangle, we take length times width. So according to this one, we have the areas is 270. Your length is 15 plus x. And then your width is 9 plus x. Using the formula, we're able to set up the equation that we can solve and find out what x is. Okay, so we're going to solve this. So 270 is, so here I'm going to distribute the 15. So I have 15 times 9 is going to give me 135. Then 15 times x is going to give me 15x. And then I have to do the same thing with the x. So x times 9 is 9x. And then x times x is x squared. So I have 270 is 135 plus, now these two are like terms, so when I add those I'll get 24x plus x squared. Okay, this is a quadratic equation because of the x squared. My goal is to find out what x is, so since it's a quadratic equation, okay, first thing I need to do is to set this equals to 0. Okay, I would have to minus 270 to make it come out to 0, and then I have to minus 270. Okay, so this whole thing is 0. 135 minus 270 is going to give me negative 135 plus 24x plus x squared. And this cannot be solved by factoring. Okay, so I'm going to use the quadratic formula to find out what x is. Okay, so first thing I have to do is to identify the a, b, c. So my a is 1. My b is 24. And then my c is negative 135. Okay, so A is the coefficient of x squared, B is the coefficient of x, and C is your constant. Okay, so I'm going to use those numbers to plug into the quadratic formula. First number is opposite of B, so opposite of 24 is negative 24. Plus or minus square root of 24 square. Take away 4 times A times C. Okay, so that whole thing, divide by 2 times A, so that's going to be just 2 times 1. All right, so now we're going to simplify. So simplify here, I have x equals 2, negative 24, plus or minus square root of 24 squared. 24 times 24 is 576. So here you have negative 4 times 1 is negative 4 times negative 135 is going to be positive 540. Okay, and then that whole thing divided by 2. All right, so continue with this. I have x is negative 24 plus or minus square root of, okay, got to add these two numbers. That is going to give me 1116 all over 2. Okay, so notice I have a plus or minus here, right? So I would have to evaluate square root of 1116. Okay, but only one of these number is going to matter because the other one's going to end up with a negative number. So I only have to evaluate one here. Okay, so that would be x equals to negative 24 plus square root of 1116, and then whatever that number is, divide by 2. Okay, so I'm going to have to use a calculator for this one, and I'm going to get an approximation because that's not a perfect square. So it's going to be negative 24 plus, okay, square root of 1116 is around 33.4066. And then divide that by 2. And this is going to give me an approximation, since I have to round this to the nearest tenth, it's going to be 4.7 feet. So going back here, the value of x has to be around 4.7 feet. You have to increase the length and the width by about 4.7 feet in order to come up with the areas of 270 square feet. So here you are looking for 3 consecutive positive integers such that the product of the median integer and the largest integer is 72. What we know is that the product of the middle integer and the largest integer is 72. Okay, so we can set up an equation just based on those. Okay, once we have an equation, we can solve for what we're looking for. So now I'm going to give a name for each of these integers. The first consecutive positive integer. Okay, I'm going to call that x. Okay, we don't know what that number is, so we call it x. Now, because we know what our first consecutive positive integer is, okay, we can come up with the second one. So second consecutive positive integer is going to be one more than what the first one is. So that is going to be x plus 1. Okay, and then the third, which is the largest one, consecutive positive integer, is going to be whatever x is, you're going to add 2 to it. So now we can go ahead and set up an equation because we know that product of the median integer and the largest integer is 72. So product is multiply. So that means we're going to take x plus 1 because that's the middle one. And then x plus 2 because that's the largest one. Okay, when we multiply those two numbers, so x plus 1 times x plus 2, okay, we get 72. So now we have an equation that we can use to find out what x is. Okay, so we're going to solve this. So first thing I have to do is get rid of the parentheses. So that would be x times x, and then x times 2. So x squared plus 2x. And then do the same thing with the 1 times x, and then 1 times 2. So that's going to give me 1x plus 2, and then bring down 72. Okay, so x squared, 2x and x are like terms, so we can collect those and make it a 3x. And bring down the 2, and then bring down your 72. So now this is a quadratic equation because of the x squared. Okay, so we have to try to solve this by factoring, by completing the square, or by using the quadratic formula. So let's see. So first thing I need to do here is to set this equals to 0. So I would have to minus 72 and then minus 72. So my new equation is x squared plus 3x take away 70 is 0. 72 minus 72 is 0. I'm going to try to solve this by factoring. Hopefully I can do it because this will save me a lot of time. Okay, so to factor I would find a times c. So a is 1. And then your c is negative 70. So that's going to come out negative 70. And your b, here's your b, going to be 3. So now we have to come up factors of negative 70 that when we add those numbers comes out to 3. How about we try 10 and 7? Okay, one of these is a negative number. So the 7 has to be a negative to make it work. Okay, so 10 times negative 7 is negative 70. 10 plus negative 7 is positive 3. These are the two numbers we're looking for. Okay, so now we can use those two numbers and put it in factor form. So x plus 10 times x minus 7 is 0. So here it's going to be x plus 10 is 0, and then x minus 7 is 0. So this is going to give me negative 10, and then this is going to give me positive 7. Okay, so this one is no good because we are looking for consecutive positive integers. So negative 10 is a negative integer. So the only number that's going to work for this situation is 7. Okay, so let's go back up here. So we found x to be 7. So x is 7. So the first number is a 7. And then the second number is 7 plus 1. That's going to be 8. And then the third number is 7 plus 2. And that's going to be 9. So the three consecutive integers are 7, 8, and 9.